Hello students, my name is Shashank Shekhar. So let us start the exercise of electrochemistry. The first question says that we have to arrange the following metals in the order in which they displace other from the salt of there. Okay, so basically, what do you mean by salt? If you think of salt, suppose we have the Al. Okay, so we can think of a salt like suppose SAL, SO4 whole thrice, and this will be twice. Okay, so this is the meaning of salt. Now it is asking that if this aluminium has to displace something, then which elements can it displace? Basically, you can think of it in a way that suppose Al has to go to Al3 plus, right? To make the salt. You can see very clearly it is going from Al to Al3 plus. Now in that process, it is getting oxidized, right? So basically, whose oxidizing power is greater will be forming the salt first, or it will displace, right? It has the same meaning. It will displace easier in the most easy fashion, right? So the one with the greater oxidation potential will get oxidized. So the question is in this way. Now, for that, you must need the oxidation potential. Now, if you see in this question, it is not mentioned. So you don't have to worry about it, right? Because whenever you get such a question in exam, you must be given the values of either the reduction potential or the oxidation potential of each of this. So if it is not mentioned in the question, I'm giving it right now from a table that I have. And you can just refer to NCERT table also. There also it is given. So let us write for each of this. So in NCERT, the reduction form is given, right? Suppose the starting is from aluminium. So for aluminium, I'm writing it here. E naught reduction potential. So Al3 plus will go to Al. Okay. So this value is given as minus 1.66 volts, right? Then we have the copper. Okay. So the copper will have Cu 2 plus. Okay. Copper 2 plus. So if you look at the table, copper 2 plus oxidation reduction value is given as 0.34. Next we have Fe3 plus. So this value is Fe3 plus Fe, and it is given as 0.77. And for magnesium, so it will be 2 plus. So in this, you have to take the most stable oxidation state, right? Suppose if Fe3 plus to 2 plus is given, we will not take it because we are asking about Fe replacing the salt, not Fe2 plus replacing the salt, right? Okay. So next is magnesium 2 plus. So magnesium 2 plus value is minus 2.37. And the last one is zinc. And this value of Zn2 plus to Zn is given as Zn2 plus to Zn is given as minus 0.76. So these are the reduction values. Is it clear? Now, the one which has a greater reduction value will have the smallest oxidation value, and it will be displacing the salt in the least way, right? Means it has the least tendency to replace the salt. So what we have to arrange? The order we need is the one with the greater oxidation potential. It is written, we have to replace it in increasing order. Arrange the following metal in the order. So it is not mentioned increasing or decreasing. So I am writing it in the way of increasing order. So one with the least reduction potential will have the greatest oxidation potential. So which is having the least value of oxidation potential, reduction potential. So this is least, this one. So negative will be already least. And the one with the greater value of negative will be the least value of oxidation potential. So it will be the highest oxidizing agent. Okay, the first will be magnesium. Then, so I'm writing in a decreasing order, not in the increasing order. I'm writing in the decreasing order. Then we have second as 0.1.66 volts, which is for aluminium. Okay. After that, it is zinc. Talking about the reduction potential of these two. So this one is least among these two. So this is copper. And the last one is Fe. So this will be our order. Okay. Is it clear to you? Did you get my point? What I'm trying to say? So basically, we said that, okay, so we have to say this, write them in the order such that the one with the greatest tendency to replace the other with the salt. Okay, so basically we are forming salts of Al, so it is getting oxidized, Al to Al3 plus. Now, to get oxidized, it must have the greatest oxidation potential or the least reduction potential. So the one with the least reduction potential is this. So we place it in the first order. Then the second is aluminum, then zinc, then copper, and then iron. So this is our order. Now let us see the answer: magnesium, aluminum, zinc, copper, iron. Magnesium, aluminum, zinc, copper, iron. Okay, so I think copper value is 0.34. Okay, so this is least, right? I think this is given wrong. No problem. This will be copper. This will be iron. So depending upon the value, if suppose the value the NCERT must have taken is less, I don't know. So you just refer to the table one more time and see accordingly. So this is the first question. Clear? Now let us move to the second question. So what does the question says? So it is says that we are given the standard electrode potential of the following species. So it is basically K plus 2 K, Ag plus 2 Ag, Hg2 plus 2 Hg, Mg2 plus 2 Mg, and Cr3 plus 2 Cr. Now what we have to do is to arrange this metal in the increasing order of reducing power. Let us now recite the question one more time. So what we have to do, we have to arrange the metal in the increasing order of reducing power. Now, which one will have the greater reducing power? So we are talking about reducing power. So if something has to reduce something, okay, so it must have a greater potential to oxidize. Did you get my point? So if something is oxidizing easier, means it has a greater power to reduce something. Clear? So which will have the greater reducing power? The one with the greater oxidation potential or the one with the least reduction potential, right? So now let us arrange them. So we have to arrange the metal. So I'm writing the metal. So which one has the least value of reduction potential? If you see here, there are three negatives: K plus K, Mg2 plus Mg, and Cr3 plus Cr. But the least one is Mg2 plus, the K plus K, right? So the potassium will have the least value of reduction potential. So it will have the greatest oxidation potential and hence the highest reducing power. So it is potassium. Then after that, we have a negative value of Mg. So we will place magnesium here. Then we will place chromium here. Now which one is having a least value? Of course it is Hg, that is our mercury. And one with the highest value of reduction potential will have the smallest reducing power. So this is the order. Okay. So I'm repeating it one more time. So you can see very clearly here it is given the values of reduction potential. And whenever you are asked such a question, you will be provided with the values. Okay. So you don't have to worry or you don't have to learn or say remember all these values. It will be given in the question. Okay. Now, if I ask you E naught, so what is this? Suppose what value is given? So you must be repeatedly going through this that it is E naught value. But it is E naught value. Okay, so if I ask you how you will write this, so a more appropriate way would be E naught K plus going to K, and its value is 2.93 volts. Okay, So why I'm writing it E naught? Because in the question itself it is given the standard electrode potential. So they are the standard value. So I'm putting a naught. After that, so since K plus is going to K, we are having a reduction. You can see very clearly K plus will take one electron and then it will go to K. Okay. So we are adding one electron, that is we are reducing. Right? So since we are going from K plus to K, so I'm writing it in this fashion. Now if I ask you to arrange each of them in the fashion of reducing power, reduction value. So the one with the greatest reduction value is which one? It is Ag plus. Okay. Then what we have? We have Hg2 plus. Then the highest value is Cr3 plus. Okay. We have K plus. At last, sorry, not K plus, Mg2 plus, and then we have K plus. Is it clear? Okay. Now I'm giving you a task. Just write the oxidation potential of this, all of this. Okay. So what will be the oxidation potential in the way I have written? Okay. So E naught, like the E naught one. Why am I saying so? So you must remember the concept. So whenever you write the oxidation potential, just reverse the sign you have in front of the numerical value. So suppose if you are writing the reduction potential of this oxidation potential of this K plus K species, then it will be written it as E naught K to K plus, which is the oxidation potential. The sign will be reversed. So it will be from negative, it will go to positive. So 2.93 volts. Similarly, you can write it for each of this. Now, let us see the order. K plus, Mg2 plus, Cr3 plus, Hg2 plus, and Ag. The same order is written here also. Clear? Now, try this question by yourself, okay? So if you have done something, some of the questions you can do it in a click. That is the first and the second. If you have done, good. If you're not done, all good. I will just explain it to you. Okay. So it is good to make mistakes, right? So if you have done a question right, maybe you may attempt it in the second time wrong. But if you have done it wrong in the first time, then you will remember that yes, I have made a mistake. That would be more beneficial, right? So it is good to make mistakes. Okay. So what does the question says? So we have to depict the galvanic cell in which the reaction is in this fashion, right? So what is the reaction going in which way? We are having a zinc electrode that is going to Zn2 plus, that is in the solution, and we have a silver plus aqueous salt of this silver plus ion, which is going to silver solid. Is this clear? Now, what we have to show, which of the electrode is negatively charged. So we have two electrodes, right? The zinc solid and the Ag solid. Okay, so we have electrode of zinc, we have electrode of silver. So for this, let us use our mnemonic device, which goes as LOA and lone, and it's abbreviated as left side. We have the oxidation, and it happens at anode, and anode is negatively charged. Okay, so let us see this. So which one is having oxidation and which one is having a reduction? So let us write the oxidation half reaction and reduction half reaction separately. So let us bifurcate this reaction. Oxidation half reaction. Okay, so let me write it properly on a board. Oxidation half reaction. Okay. So the one which is losing electron is zinc is going to Zn2 plus. It is losing 2 electrons, so it will be written in this fashion. Zn is going to Zn2 plus by release of 2 electrons. Okay. Ag is going to Ag plus, I would say, not Ag. Ag is going to Ag plus is going to Ag. That is the silver ion going to silver solid by release of by gain of 1 electron. Now, can we add this reaction? Both of this reaction, are they good enough? No, they are not good enough. Why they are not good enough? Because I have said you earlier that the number of electrons should be same. Okay, it should be same in each of these. So you can see very clearly that the second reaction, that is a reduction half reaction has 1 electron, whereas the oxidation half reaction has 2 electrons. So what we will do simply is multiply the second equation by 2, our reduction half reaction by 2. Each of this will have now a coefficient of 2. Now if you add both of these equations, the 2 electrons of this and 2 electrons of this will be cancelled out. Okay, so this should be noticed. Okay, this is important. It's important to do so because whenever you solve the EMF, to find the EMF, you're giving the cell representation. You have to write the half reactions, then you have to add and find the final reaction. Okay, so in all that process, you must have the correct coefficient with each of this, or your Q value or the equilibrium value will be different. Okay, now coming back to the question, so which one is negatively charged? So which one is anode? The oxidation is happening of zinc. The zinc will be the anode, so it will be negatively charged. So this is zinc. Is it clear? So just go step by step. So once you go step by step, you will not make a question. There is a less chance of making mistakes. And when you are used to it, you will find a shortcut by your way. Okay. Now, second question: the carrier of current in the cell. So what will be the carriers, right? So this is a very good question to ask. So you must have studied electrostats and all, static electricity, current electricity in physics, where you have studied that your metal body regulates current, or you can say provides current by the flow of electrons, right? But in the case of electrolytic cell, we have seen this, that in the container there is a movement of ions, right? Not the electrons. So what is the charge carrier in the current? What will be your answer? Your answer should be ions. Okay, both cations and anion. So why I'm saying cations and anions? You must ask this question: why? When do we say something is carrier of current? So the answer comes from that. What is current? Some simple definition of current is flow of charge per unit time. This is the simple definition of current. So what should flow? Charge should flow. Then only current will be observed. What are these cations? They're charged particles. Okay, they have a charge on it. Like if you talk about Ag, it has a charge of +1. If you talk about Zn, it's a charge of 2 plus. So they are the charge carriers. Okay. Now, what about the individual reaction at each electrode? So we have done it at the first time only. Zinc solid will go to zinc 2 plus aqueous with the release of 2 electrons. Simultaneously, we have the 2 moles of silver plus ions, which will take 2 electrons and go to silver solid electrode. So is it clear to all of you? So we have written the half reaction. So we are done with this question. Now let us look at the solution. So here is the solution. Okay, cool. We have written this. We got zinc electrode. So I would suggest you must try to write the cell representation value in this way. Okay, so you must try it. How it is written. Just try to sense it. Make a logical way to write it. I have explained the way to write it. You must try it by yourself. Now, ions are the carriers, as I've told you, and in the external circuit. So we have an external circuit. Current will flow from silver to zinc. Okay. If you just see this, 2 electrodes. We have a solid bridge, and this is the external circuit. Okay, so this is the external circuit. Now, talking about the half reactions, if I would suggest you to write it with the multiplicative tool, so that would be more good. Okay. So this is our solution. Now, let us move to the next question. The question says we have to calculate the standard cell potential of galvanic cell in each of the following reaction take place. In which of the following reaction takes place. Okay. So what we have to do, we have to say see that in which of these the cell reaction will happen and which of these the cell reaction will not happen. How we'll do it? Say where you have to derive the concept from. So I'm giving you a hint. Just remember the thermodynamic part of our chapter. What was it about? Okay. So if you have remembered, well and good. Not remembered, I'm telling you, it is Gibbs free energy. Okay, so we've studied there. That in the Gibbs free energy part, if we have a E naught value as positive, the whole delta G becomes negative. Okay. So let me write the equation for you. The equation goes as delta G naught is equal to minus NFE naught in case of standard, or you can write it for both ways, no issues. So since it is asked for the standard, so we are talking about this now. Okay, now let us see what are the terms here. N and N. N is a count. It is simply a count. It will never be negative, right? Counting numbers are never negative. You never count something as minus one apple, minus two apple, right? So it will be always positive. Talking about Faraday's constant, it is 96500. It is a constant. This value is fixed. It will never be negative. Now, the delta G or the spontaneity, I would say, will totally depend upon the E naught value. If this value is positive, the delta G naught will come out to be negative, and we know that for negative value of delta G naught, the reaction is spontaneous and the reaction will happen. Okay, right. Now let us calculate the E naught value for each of this. So I would write here that the criteria for the reaction to happen is that E naught should be positive. Is this clear? Okay. Now let us write it. So calculate the stand potential in which the following reaction take place. Now, if you see here, we have chromium going to Cr3 plus. Okay, chromium going to Cr3 plus. So what we need is this value. But what we are given is this value. So we are basically provided with the reduction half reaction reduction value, but we need the oxidation value. Okay, so as I've told you, how you can convert it? Very simple. Just revert the sign. Okay, just revert the sign. You will get it as 0.74 volts. Now, which species is getting oxidized? Sorry, reduced. So the value would be CD2 plus to CD. This one is getting reduced, and the reduction potential is given as minus 0.40. Okay. Now, if I ask you how you can calculate the E naught value, so we have a simple formula for that. The one species which is getting oxidized and the one which is getting reduced, just take the value, simply add it, right? So minus 0.74 minus 0.40. That will give you a total value of how much? It will be 4 will be 4, 7 4 11 minus 1.14 volts. Okay, just remember to write the unit. It is very important. Okay. Now the value is minus 1.14. So are we meeting the criteria? Are we good enough with it? No. Because we need a positive value, right? And it is negative. So this reaction will be non-spontaneous. Okay. The value will be this much and it will be non-spontaneous. Now, interesting question. How you will make this reaction spontaneous? How we can do it? Say, what will we do it? We will provide a current, okay, a current such that the potential is greater than this value. Okay, and not with the negative sign. I'm talking about the absolute value. What is the absolute value of 1.14? Okay, so we'll just provide a current in the opposite direction with a potential value of potential value that is greater than 1.14. Okay, and then the cell which you will get will not be a galvanic cell, of course, it will be electrolytic cell. Okay, so we are done with the first question. Now just try the second question. Okay, do it right, do it wrong, just try to do it. Just write the half reaction, see which is getting oxidized, which is getting reduced, get your values from the given information and just add them. So I'm starting it to write the answer. You just match your answer and you see where the mistake goes. Okay. The first species is Fe2 plus, which is going to Fe3 plus. Fe2 plus is going to Fe3 plus. Okay. So here you can see very clearly the charge, positive charge is increasing. That means we are losing one electron. So we can write here plus 1 electron. So since it is losing 1 electron, this is getting oxidized. So we need this value absolutely. Fe2 plus going to Fe3 plus. But we are given the opposite value. Why? Because we are given the reduction value. So what I have told, we have seen in the first question right now, that we have to just reverse the sign. Just multiply it with a negative sign, that will reverse your sign, that will do your work. It will be minus 0.77 volts. Okay. Now, let us move to the next species. So it is going from Ag plus. Okay, so I missed the phase of each of this. So you must be very attentive with this because writing phase is very important. Okay. So aqueous is going to aqueous. Here we have an aqueous solution. It will take one electron. It will go to the solid phase. Okay. Now, how you write the E naught? You write E naught Ag plus is going to Ag. The value is given as 0.80. We don't have to reverse the sign because it is already in this fashion only. So it will be 0.80 volts. Now, just add this value. What you will get the E naught cell? It will be minus 0.77 plus 0.80. That will give you a value of 8 minus 7, 1 and 0.17. Now we are good. Okay, so it has a positive value. The reaction will be spontaneous. So this will be spontaneous. And the first one will be non-spontaneous. Okay, so we are done with the first part. Now let us see the second part. So it is asking to calculate the delta G naught value at the same time. And in addition to that, we have to calculate the equilibrium constant. See, we have covered almost every concept in this chapter with this one question. Okay. So let us start to find the value of this. So first about delta G naught. So if you have noted, we have found the value of this as how much? It was 1.14 minus with a negative sign. Okay, so this was the E naught value of the cell. So what will be the delta G naught? So I would say one thing, that in case of electrochemistry, the notations are very important. Okay, so you must be very clear with the notations, right? So I'm each and every time I'm writing it, I'm just pronouncing the notation each and every time so that it get effective in your mind. Now, value of the formula is minus NFE. So for this, you have to write the reaction, right? So let us write the reaction first of all. Cr is going to Cr3 plus. Because we need the number of electrons, so we have to write the reaction. 3 electron. And Cd2 plus is taking 2 electrons and going to Cd. It is in solid phase. aqueous phase, and solid phase. Can we add this? Are we ready to add this? No, we are not ready to add this. Number of electrons is not same. What we will do, we will just multiply with a common factor. Suppose I multiplied with 2, multiplied with 3. What you will get? You will get 6 here, 2 here, and 2 here. Okay. You will get 3 here, 6 here, and 3 here. Now, after adding, write the final equation. 2Cr 3Cd2 plus 3Cd2 plus E plus 2Cr3 plus and 3Cd. Let us match it with the equation that is given. So we have a coefficient of 2, 3, 2, 3. CrCd2 plus Cr3 plus Cd. CrCd2 plus Cr3 plus Cd. Okay, we got our final equation. So our number of electrons is correct. So we got the value of N as 6. So we'll put this value here. The formula is minus NFE, right? So N is the number of electron, that is 6. F is the Faraday constant. So I'm taking it as 96500. You should also take this value until and unless it is not mentioned in the question. Okay. It is with a negative sign. Just multiply it. So I'm multiplying it quickly because we are going out of time. So we will do it quickly on calculator. I would suggest you must try it by yourself, right? Do not use calculator because in exams you will not get one. So 6 multiplied by 9650 multiplied by 1.14. That will give a value of 6600 Now one more suggestion from my side. Since it is coming in joule, try to write this in kilojoule always until and unless it is not mentioned in question. Okay. So to write it in joule, we have to move this point here. That will give you a value of 660.06 kilojoule. Is it clear? We have solved it very efficiently, right? We've seen each and every step. So the first one, we got it as 660.06. Now let us look at the second question. So for that, what value did we get earlier? E naught of this, we get it as 0.17. Okay. The positive sign. Now let us try to write the reaction. So we have Fe3 plus Fe2 plus going to Fe3 plus. So we have a release of 1 electron and we have Ag plus taking 1 electron going to Ag. Write the phases here: aqueous, solid, and this is also aqueous. Now in this question, you don't have to worry about electron as it is already same, right? So it will be cancelled when you add each of this. The final value would be Fe2 plus aqueous, Ag plus aqueous, Fe3 plus and Ag solid. Okay, so we are good with the equation, right? We don't have a coefficient, we have only one. Now you can see very clearly number of electron is 1, so N will be equals to 1. What will be delta G naught value? It will be minus 1 multiplied by F 96500 and 0.17. So what will be the value? 96500, 0.17. See, we got a negative value. It is spontaneous. Okay. 96500, 0.17. Right. So that will give you 16405.0 kilojoule. Convert it into, joule. Convert it into kilojoule. So we'll move 3 decimals back. That will give you minus 16.40 joule. Okay, we have done this question. Now let us see the solution. Okay, so we have done the same thing. Now let us move to the next question. Okay, one more thing here. Yeah, we have to find the value of K. Okay, we have find the value of K. So I'm doing it for the second one. You do it for the first one, right? If you remember the formula was like this: delta G is equals to delta G naught plus RT ln K. So this is the formula we have. Okay, the standard formula. Now for equilibrium, this delta G will be 0, LT ln Q, I would say. Now for equilibrium, delta G will be 0 and your Q will be equals to K. If you put this value, you will get it as delta G naught is equals to minus RT ln K. Isn't it? Okay. Now we have the value of delta G naught. So we have to find K. So if you write it, it will be K will be equals to minus delta G naught by RT e to the power. So how we have done this? So if you don't understand, just see. So I'm writing the middle part. So once this RT goes here, the negative sign goes on this side. We get that as RL ln ln K. So whenever you remove a ln K, you get e to the power on the other side of the equation. Similarly, if you have log K, suppose something is given as log K is equals to A, suppose. So if you remove the log on the left side, you will get 10 to the power on the right side. So to find the value of K, okay, so this will be K. To find the value of K, we have to take it as e to the power minus delta G naught by RT. Okay, just put the values. So we get it as minus 16.40. What will the value of R? It will be 8.314 and this will be multiplied with temperature. So we have the standard temperature and it is 25 degrees Celsius because we are taking the standard condition. So remember this value. So at standard condition, the value of temperature is 25 degrees Celsius or 298 Kelvin. Right? Put this value here. Evaluate this. So once you evaluate this, so in the exam you must be given the value of e to the power, the value you get. Okay, so don't have to think about it, right? That how you will calculate in exam. Multiplied by 298. Okay, so reverse it, multiply it with 16.4. So here one mistake I have done. See, we have taken a kilojoule value, right? So we cannot take it. We need the joule value because all of this R and all, it is 8.314 joule per Kelvin per mole. So you must take the joule value. It is multiplied by 1640 with a negative sign goes e to the power will give you approximately 0.48, right? This will be your answer. Okay, maybe I would get a wrong numerical value. Don't worry about it. Just concentrate on the process. Try it one more time. If I have done it wrong, just follow the same path. You will get the right answer. Okay, the path is absolutely right. Okay, now let us move to the next question. So see, we have taken a wrong value of 0.03. So once you subtract it, you will get it 0.03. Okay, so we have done a mistake here. So I was just confused about it. Why the value is coming in this fashion. Okay, so it is 0.03. So once you get this value, and they have taken 96487, you can take it 96500. It is not mentioned in the question. Then just take the anti-log and solve it. Okay, just try it by yourself. Now, next question, we have to write the Nernst equation and the EMF of the following cell. So you have to write the Nernst equation. But first, we'll write the Nernst equation for this. I will write it. Say, what is the Nernst equation says? It goes as E cell is equals to E naught cell plus RT by NF ln Q. Now, let us concentrate on this term first. Let us just simplify this. So, RT by NF ln Q can be written as log Q. So, this is 2.303. 2.303 RT by NF. Why am I writing this fashion? Because you take any value, right? ln A, suppose I'm taking arbitrary number, then it can be written as 2.303 log. This is just a standard thing to write. So you must be very aware about logarithm. If I'm saying this, as I mentioned one more property, just write them in one place because this is very important throughout the chapter, especially to electrochemistry. Right? So I'm writing it in this fashion. So what will be the final E cell? E cell. One more thing, this value, excluding this n, okay, so 2.303 RT by F value is 0.0591. So remember this, it will help in your exam. Divide by n log Q. Now we are good to write the final equation. E cell is equals to E naught cell plus 0.0591 by n log Q. So this is your required equation. Just simplified it. So you can do your numerical easy in an easy fashion, right? Just try to solve it. So we don't have the E naught value. So we have the problem here of not having the E naught value. How we will write it? So let us see the E naught value. So you can take the table. In the exam, you don't have to worry about it. These values will be given. So first of all, let us write the equation. Okay. Let us write the equation for this. So we are going from Mg to Mg2 plus. Okay. We are going to Mg to Mg2 plus. And the second species is Cu2 plus to Cu. So it will take 2 electrons. It is good enough to take 2 electrons. It will take the one Cu2 plus Cu. Are the electrons balanced? Yes, of course they are balanced. We don't have to worry about it. So whenever you add this equation to equation, these 2 electrons will be cancelled out because they are on the opposite side. One is on the LHS, that's on the left hand side. One is on the RHS, that's the right hand side. So once you add this, you will get the required cell reaction or the cell equation, I would say more appropriately. So Mg, what about the states? It is solid, aqueous, solid, and aqueous. Okay, so these are salts, so they will be always dissolved in water. They are electrodes, so it will be obviously in solid form. Final equation would be Mg solid plus Cu2 plus aqueous. That will give you a value of, that will give you on the opposite side Cu solid plus Mg2 plus aqueous. So we got the final cell equation. So why we did this? There are many benefits of this equation. First, you got the number of electrons, that is 2, which will be the value of n. Okay, you got the species which is getting oxidized, the one which is getting reduced. Although we got it from this thing, that is our cell representation, but to write it in a bifurcating way is much more appropriate. Okay, so which one is getting oxidized? Mg is getting oxidized. So we need the oxidation potential. But whenever you will get always the reduction potential. In case you get the oxidation potential, it is good. So I am repeating it one more time that just try to identify the E naught value. Why I am trying to say it? Because this means that Mg2 plus is going to Mg. If you are given a value in such fashion, right, Mg is going to Mg2 plus, then do not think it as a reduction value. It is given the oxidation value because the one which is on the left side is the reactant and the one which is on the right side is the product, and the slash is given to maintain the interface. Okay, so if your value is given in this fashion, suppose, so its oxidation potential is basically 2.37. So I also don't remember it. I'm saying it from the table, and you don't have also to remember it. So you will be given the value, right? So this is 2.37. So what will be this value? minus 2.37. Just change of sign. So which value we need? Of course, we need this value. The second species is Cu2 plus to Cu. So that value is given as 0.34. The reduction value is given as Cu2 plus to Cu. That is 0. Okay, so let me see it again. 0.34. Okay. Now, what will the E0 cell value? Just add the potentials, right? The one which is getting oxidized, add the oxidation potential of that with the one which is getting reduced, the reduction potential of that. So the value will be 7411, 33617 and 2.74 volts. Okay, so you got a E0 value. Just put this value here. So E cell will be equals to 2.37 plus 0.0591 divided by n. That is the number of electrons. And you can see very clearly in the previous, page, it is 2 electrons. Okay, so it will be 2 electrons. ln Q, how will write it Q? See the equation, cell reaction. For that, refer to cell reaction. So this solid will have a concentration of unity, that is 1. So we have a change of concentration in the aqueous form, that is Mg2 plus. So first the product on the upside, that is on the numerator, Mg2 plus. Again the bracket to represent, it is log. Okay, so this one is log. The bracket to represent that is, we are writing the concentration. Second species is Cu2 plus, that is on the reactant side. So are we given the value of each of these? Yes, of course we are given. It is 0.001, 2.37, 0.0591 by 2 log. Mg2 plus is 0.001 divided by Cu2 plus is 0.0001. Just solve this simple arithmetic. 2.37, 0.0591. So this will be log 10 and its value is 1. So finally just add the simple arithmetic. So let me do it. You can do it by yourself. I'm doing it on a calculator because we are lack of time. We are running out of time. So 0.0591 divided by 2 plus 2.37. So finally this value would be 2.399, approximately I would say 2.4. Okay, so we have done it right or wrong, just match it with the solution. If not, just solve it again. I must have done a numerical mistake, but the process is absolutely right. Okay, just trust the process, put the values, you will get your answer. Now try to do it this one. I'm giving you 2 minutes, right? Just try to do it by yourself. So I'm starting it on the first page. You do it on yourself. Okay. First of all, write the half reactions, Fe2, Fe2 plus. The release of 2 electrons. Second is H plus 2H2. So here, first of all, balance the hydrogen. They will take 2 electrons and H2 will form. Write the phases, this is gas, this is solid, this is aqueous. Okay, this is aqueous. Now add this equation, you will get the final cell reaction. Fe solid, 2H plus aqueous. Electrons will be cancelled out. You don't have to worry about it. Fe2 plus aqueous and H2 gas. Now let us write the final QL. Okay, Q value. So we got this equation at the final equation. Now what we will do? Say we got the final equation as this. What was the next step? I told you just now, write the Q. Okay, you have to write the Q. So Q will be equals to, that is our reaction quotient, will be equals to the product concentration, that is our Fe2 plus. So the concentration of Fe2 plus divided by the concentration of the concentration of H plus. Okay. Now all the students just focus on this, right? We have to give the square. Why we have to give the square? We have learned it in equilibrium. So the coefficient power should be there. So the coefficient should be present as the power. So all of these species was having a coefficient of 1. So we didn't put any power or something like that. But here we need to put the power because H plus has a power of coefficient of 2. So it will have a power of 2. Next, let us write the equation. So what is the number of electrons involved here? 2. Okay. So let us write the final equation. It was E cell is equals to E naught cell. Okay, so we have to calculate the E naught cell value also. How you will calculate it? So for Fe2 plus, so let me see the value for Fe2 plus. So we are going from where to where? We are going from Fe to Fe2 plus. Okay, so we need the say we need the reduction potential or the oxidation potential. So usually you are given the reduction potential. So its value is given as say Fe2 plus or Fe3 plus. It is Fe3 plus. Okay. So its value is not given, right? So let me search it for you. Fe2 plus standard electrode potential. Okay, standard electrode potential. Okay, so let me incorporate you with a one more very interesting concept. So I think you will need it. So that's why it is not given, right? So you are given two values. Okay, so this is very important concept. I missed it. Sorry for that. So let's just focus on this concept. So we know that Fe3 plus 2 gives takes one electron and goes to 3 electrons and goes to Fe. So this value is given, right? And one more value is given, that is Fe3 plus taking one electron going to Fe2 plus. So this value is given. Okay, so this is good. So can we just add both of this and get the final value? So first we have to reverse this value, right? So this value is given as Fe3 plus to Fe2 plus. I think it was given as, so Fe3 plus is given as 0.77. Okay, so this was given as 0.77. Okay. Okay, I got the Fe2 plus value. Okay, so this is given as Fe2 plus is given as minus 0.45. Okay, so we got the value. So I will teach this concept later on. So since I got it, so we will focus first upon the question. So this value is minus 0.45. Okay, so I will get back to this. Now, and the second thing, the second species is what? The second species is H plus OH2. So what will be the value for this? Say, you must remember at least this value, right? So it is 0, right? It is 0. So the species that is getting reduced. So is it getting reduced? Fe is going to Fe2 plus. No, it is getting oxidized. But we are given with the reduction potential. So we have to convert it. So the oxidation potential will have a just opposite sign. So we'll write the value as 0.45 plus the one bit is getting reduced, it is H plus and its value is 0. Just put this value. This is the final E naught cell. Now let us finally put this value in the last equation. E cell is equals to E naught cell, that is 0.45 plus RT by NF. Okay, its value was calculated earlier, it is 0.059. NF is 2 electrons are required, log Fe2 plus concentration. Okay, so we have seen Q value as Fe2 plus concentration by H plus concentration square of H plus concentration. So this value is given as 0.001. This is 0.001, and on the denominator we have the H plus concentration as 1. Okay, so its square doesn't count anything. Finally, 0.45 plus 0.059 by 2. So log 0.001, it is log 10 to the power minus 3, and it is absolutely minus 3. So if you don't know, so if you have to find the value of log 10 to the power anything x, so that will be the value of this. Okay, so since it is 10 to the power minus 3, so we will multiply it with 10 to the power minus 3. Now let us just use the calculator so we can do it quickly. So 0.0591 divided by 2 multiplied by 3, that will give you an approximate value of minus 0.08865. Okay, and we have to add 0.0545, that will give you a negative value. Okay, 0.04365. You get it? Is it clear? So this is the final value. Now next question. So we got this. So try the next question. So I'm giving you the values right now, just try it. Okay, so try it by yourself. So the E naught value for Sn going to Sn2 plus is not given. It is Sn2 plus 2Sn is given, and this value is approximately 0.15. Okay, it is 0.15, and second species is again H2. You know its value very clearly. It is 0 volts. Okay, so all of this are in volts. I'm giving it 2 minutes to try to solve it by yourself, then we will solve it. Okay, try it, whether right or wrong, just try it. Okay, you have more 30 seconds to solve. At least write the Nernst equation. Don't solve it, just write the Nernst equation, put the values. At last your answer will be calculated. That is just a numerical thing. Okay, so let us start the solution. So first of all, write the equation. We are going from Sn to Sn2 plus. This will release 2 electrons. It is solid. And we have the another species which is going from 2H plus, taking 2 electrons, going to H2, it's gaseous, and this is aqueous. Just add these equations. We'll get the final equation. This 2 electron and 2 electron will be cancelled out. So Sn solid plus 2H plus aqueous, Sn2 plus H2 gas. So this will be the final equation. Here we get the N, value of N is 2. We can get our Q. What will be Q? So I'm not considering this H2 gas because you can see very clearly its pressure is always as 1. Okay. So how you will write Q? First of all, the concentration of tin plus 2 plus ions. divided by H plus concentration square. Again, you will do the square because H plus has a coefficient of 2. So SN2 plus concentration, okay, divided by H plus concentration square. This is the final one. Now, starting, let us, one more thing is remaining. So we have the E naught of both of this. But what do we need? We need the opposite value because Sn is going to Sn2 plus. So we are going from Sn to Sn2 plus. So the sign will be reversed. And the final E naught cell value will be simply the addition of both of this, that is minus 0.15 plus 0, that will give you plus minus 0.15. Write the next equation. E cell will be equals to E naught cell, that is minus 0.15 plus RT by NF, that is 0.0591 by 2 log Q we have seen, that is Sn2 plus concentration by H plus concentration square. So Sn2 plus concentration is 0.05 and H plus concentration is 0.02 and this will be squared. So let us now calculate the value. So we have 0.05 divided by 0.02. Okay. Again it is divided by 0.02. Now take the log of it. Multiply it by 0.059 divided by 2. So this will give you a total value of a negative sign plus 0.061, and once we got this, just subtract 0.015. That would be, okay, 0.061 minus 0.15. It will give you minus 0.089. Is it clear to all of you? Volts. Okay, just remember to write the unit. It is very important. Next question. PT Br minus is going to Br2. So again we have a PT electrode. Because why we have PT electrode? Platinum, because bromine is gas and gases cannot be made to solid electrode. So we are using PT, which is a non-reactive metal, heavy metal, and we are using it as an electrode. So if I tell you the values of Br minus is given as 1.09. Okay. So Br2 to Br minus is given as 1.09, and it is against whom? It is against H plus. So this value is again 0. Just try to calculate it. Okay, I'm giving you again 1 minute. Just first of all calculate E naught cell, write both the reactions, write the Nernst equation. Okay. So first of all, I'm calculating the E naught value. So the species that is getting oxidized is this one. Okay, so we will write it on other way. Write it other way. So Br minus Br2, that will give you minus 1.09 volts because we are just reversing the process. Okay. Therefore, E naught cell value will be simply addition of both of this, that is minus 1.09. Okay. We got the E naught value. Good. E naught cell value. Now let us write the equation next. So Br is getting oxidized. So Br minus is getting to Br2. So I will multiply it with 2 initially so that the Br number of Brs is balanced. This will be in aqueous form. This will be in gaseous form. So again, you can see that Br2 pressure is taken as 1 atm. Second one is H plus, or more accurately, so this will be on this side. 2 electrons. This is also aqueous. H2 gaseous. Just add both of this. Electrons will be cancelled out. Okay. And you will get your final equation. So Br minus with a 2 against it. Aqueous 2H plus aqueous will give you Br2 gas and H2 gas. Here you will get a very interesting lesson to learn. Okay, so those who learn just by putting the values like this, that is oxidizes by reduce, log reduce by oxidize, and this species and that species, they will make a wild mistake here, right? So you have to be quick to your, say, your base, right? Because I've said you right now, just write the Q value. Don't write it as reduction by oxidation, oxidation by reduction. Just write the Q value. You can see very clearly what a varied change has been occurred. So for this, you will get a very complicated value, that is Br minus square, concentration of Br minus square, and H plus concentration square. So both of the species are on the downside. Okay, both of the species are on the downside. Okay, so we have the E0 cell value, we have the Q. Just now we have to write what? We have to write the E cell. So that will be E cell will be equals to E0 cell value. So E0 cell value is how much we calculated. So I'm writing it just now here. It is minus 1.09 plus 0.0591. 2 electrons were involved. Log Q. And Q was Br minus concentration square. So 0.01 square and 0.03 square, both on the downside. Okay. Now if you just calculate this value, what you will get? It will be, say, just simplify this further. Okay. That will make the calculation easier. So this will be removed, this will be removed. 10, 10, 10 to the power 4 by 3. Okay. So we have divide by 3. We will take a log of it and multiply it by 0.0591. Divide by 2 again and subtract 1.09. So that will give you a value of minus 0.98. Okay. Is it clear to all of you? So we have done a very good question here. So very important concept has been covered. So for this question, you must know how to convert this value, how to convert this cell representation into reaction. Second, you must be very aware what is the Nernst equation, what are the significance of each of this value that is given. Okay. So once you do this, put the values, you will get your answer. Let's see the answer. 2.67. This, if it is there is a mistake with the E0 value, just ignore it. Okay. So there can be mistakes. So the process will be same, right? Okay. Now let us move to the next question. So we have the next question as, in the button cells widely used in watches and all, this is the equation. What we have to find? We have to find delta G naught and we have to find E naught. First of all, we will find E naught. write the reduction half reaction, oxidation half reaction. I'm writing it here. We are going from Zn to Zn2 plus, okay, and Ag plus 2Ag. Is it good? Yes. Now, what about these things? We have this also. What about this? You don't have to worry about it, right? Because they are the salts, okay? They're part of the salt and their concentration is not changing at all. Okay, so I would not say concentration, I would say more appropriately the charge is not changing. Say they are not getting oxidized or reduced, so it will be same. Just put this coefficient to it. It is already balanced. You don't have to worry about it. Okay. So Zn is going to Zn2 plus. So it must be involving 2 electrons. Here also Ag2O. So 2 H plus Ag plus are there, right? So here also 2 electrons are being added. So N you got it as 2. Now if I soup for Ag2O to Ag, so let me see it. Ag 2O to Ag reduction potential is approximately 0.342. Okay, so this pair Ag2O going to Ag, this pair value is given as 0.342. Now you would ask that we have Ag plus 2Ag also. That value is also given. So see that value is just a aggregate of all the values. So that value is also approximately near to that, near to this Ag2O. It is 0.80. Okay, so it is varying much. Okay, so I think you should take this value. That is Ag2O to Ag plus Ag. This pair is different from Ag plus to Ag. Okay. What about Zn to Zn2 plus? So this value is given as how much? It is given as minus 0.76. So reduction potential is given. So I will write the oxidation potential. So this will be 0.76. So just add both of this to get your E naught cell value. So you will get this value as 2, 2, 7, 6, 4, 10, 7, 3, 10, 1, 11. So this will be E naught cell. What will be delta G naught? Minus 2 electrons are involved. F96500 and 1.102. Okay. Just incorporate this value and find it. So this will be approximately 1.102 is 212.686. So I'm writing it in kilojoules directly. Okay. Let us see the solution. So they have done the same thing, taken those values. It is 213.04. Okay, so they just approximated it more and made it to 213 instead of 212.7. Now, next question. So we have to define conductivity and molar conductivity. So I'm not going to the basic definition. I'm telling you the, you can say, extract of it. So discuss their variation with concentration. We have seen the graph. First of all, what is molar conductivity and conductivity? So conductivity is basically 1 by rho. So you must have studied R is equals to rho L by A, right? So that is the resistance that is offered. Rho is the resistance that is offered by suppose a metal, or in case of cell, a conductivity tube which has a length of 1 meter and an area of 1 meter square, or 1 unit length or 1 unit and 1 unit square area. Now it is that conductivity, it is that resistance. Okay, clear? Now if you take the reverse of it, so it is the say suppose, so resistance, suppose it is conductance, so it is the conductance, or you can say the ease provided by the electrolytic cell with which the current can flow when the distance between the electrode is 1 meter and the area of that of that compartment is 1 meter square cross section area. Okay, so this is conductivity. And when this same amount of area which is placed between 1 meter square has only 1 mole of that electrolyte, then that current will be termed as molar conductivity. Is it clear? Is it clear to all of you? So I have said that conductivity is the conductance that is due to the electrodes placed 1 meter apart, and the cross section area of the compartment in which it is kept has a 1 meter square. Okay, so that is termed as conductivity, and when that region which I have isolated has 1 mole of the electrolyte, then that the conductivity which will be measured will be equals to molar conductivity. Now both of the conductivity, if I talk about conductivity, then conductivity decreases. Okay, it's a clear relation, and molar conductivity also decreases. We must have seen this graph which goes like this. So this is the graph. For this graph, we have the formula lambda m is equals to lambda naught m minus a root c, where c is the concentration. So if I just place it root c, here I place lambda m. So y is equals to mx plus c. So m is the slope and x is the axis, that is root c. So m slope is minus a here, and c is the conductivity at infinite dilution. So this is the graph. And what about the relation between, say, about weak electrolyte? So we know that alpha is equals to lambda m by lambda naught m. Okay. And alpha is equal to root under k by c. K by c. So you can see very clearly here this relation that lambda m, if you just focus on two parts that we're concentrating, lambda m and root c, you can see very clearly that lambda m is inversely proportional to 1 by root c. Sorry, inversely proportional to root c. So we got this kind of graph that it is dipping. Okay. Is it clear to all of you? Right. So we are done with this question. Let us see the solution. So the same thing is written, the formulas are mentioned. You can just work out with the formulas. Once you get the concept, it is easy to do so. Okay, conductivity is this. Molar conductivity is this. Lambda is equals to kV. Okay, this is an important formula. So if you just bifurcate it, this formula goes like this. Remember the symbols. This is kappa, it is for conductivity. Lambda is for molar conductivity. And this is C, this is a concentration. And if we do the reverse of it, it will be volume, of course. After that, this is the thing that we got, the root C of the weak electrolytes. And if I talk about a strong electrolyte, okay, so it is not given here. So a strong electrolyte graph will go like this, and which will follow this equation. Whereas this is for what? This is for strong electrolytes. Whereas for weak electrolyte, lambda m by lambda naught m root under k by c, which was initially equals to alpha. This is for weak electrolyte. Okay, is it clear? Now next. The next question says that the conductivity of 0.20 m molar solution of KCl at 298 Kelvin is this much. So conductivity is given, that is your kappa is given. It is given as 0.0248 Simon per centimeter. Okay. The next thing it is mentioned at its concentration, it is 0.20 m, or we can say it as 0.20 mole per liter, or more appropriately I would say 0.20 mole per decimeter cube. So you must be aware about each of this. Okay, so this is very important. So we will just now just see this importance. Now I've made you seen the formula that what you have to calculate. You have to calculate the molar conductivity. We know the formula, lambda is equals to kappa by c. This is the formula. What is kappa here? Kappa is given as 0.0248, okay, Simon per centimeter. What about the value of this? So here it is decimeter cube, right? We have to convert it into centimeter cube, right? So 1 millicenti deci. So we centi is smaller than deci. If you convert deci into centi, you have to multiply it. So since decimeter is having inverse power, so we have to divide it finally by the given number. 10 to the power 3 for 1 decimeter cube is equals to 10 centimeter. Therefore, or we can say for 1 decimeter inverse, it will be 10 to the power minus 1 centimeter inverse. Therefore, for 1 to the power 10 decimeter cube, it will be 10 to the power minus 3 centimeter cube. So, if you put it down, it will be in this fashion: 10 to the power 3 mole per centimeter cube. Let's put this value here. 10 to the power 3 will go upside later on. Mole per centimeter cube. So this will finally, if we just calculate it, you will get this value as 0.0248 divided by 0.20. This is 0.20, not 0.020. And this will be multiplied by 10 to the power 3. So 124. You will finally get this value as 124. Now Simon will be Simon. When centimeter will go upside, it will be minus 1 plus 3, or I would say plus 2. And mole will be inverse. So 124 Simon centimeter square per mole. So we have this value, we have this value. Molar conductivity is kappa into 1000 by C, that is Simon centimeter square per mole. Is it clear to all of you? The conversions and all. The conversion is very important. It will make your very correct say suppose answer very wrong. Okay. Now next question. The resistance of a conductivity cell containing, so its concentration is given, I would say molarity is given. It is given as 0.001 at 298 Kelvin is 1500 ohm. Okay. And we have to calculate what cell constant, that is L by A. We have to calculate this value, and conductivity is of that same concentration solution. You can see the concentration is remained same, is given as, conductivity is represented by kappa. Okay, so this is given as 0.146 into 10 to the power minus 3 Simon centimeter inverse. Now here's the tricky part of this question. They have mentioned the concentration. Although they have mentioned to simplify that it is for the same resistance or conductivity or for the same concentration, but it will confuse you. So you should be aware that you don't need for this value you don't need. So let us see how we don't need this value. So we know that R is equals to rho L by A, or 1 by R is equals to 1 by rho A by L. Therefore, 1 by R is G, that is our conductance, and I will keep it as 1 by R only because this value is given. And 1 by rho value is what? This is kappa. This will go here on this side, and A by L. But what do we need? We need L by A. So L by A will be equals to R by kappa. Is it clear? So what is R? R value is 1500 ohm. Okay, so you will say this is the ohm, and that was in centimeter. So per Simon is nothing but ohm. We have seen this. Okay, so 1 per Simon is, sorry, 1 Simon, both are correct. 1 per Simon is equals to 1 per ohm. So you don't have to worry about it. You can just replace it with per Simon. Okay, the next thing that is given is what? So we are given resistance now. So it is correct. Okay. So I have done it wrong. Next is the value of this kappa. It is 0.146 into 10 to the power minus 3. 0.146 into 10 to the power minus 3 Simon per centimeter. Okay, is it clear? Are we doing it right? No, we have made a mistake here. It was R. So that is why we are not cancelling the units at all. Okay, so this will be Simon and it will be multiplied with this. Okay, so see, to write the unit is very important because unit was not getting cancelled and I was getting confused. Now I have written, instead of ohm, I have written Simon inverse. Now the units will cancel out. Simon inverse will cancel out and you will get this one as centimeter per centimeter cube. Okay, per centimeter. This value is per centimeter. Okay, so 1500 multiplied by 0.146. So it is 219 into 10 to the power minus 3 centimeter inverse. Okay, so this is A by L value. This kappa into rho is A by L value. So I would say 0.219. But what do we need? We need L by A. So L by A will be nothing but inverse of this. That is, if I write the G star, it will be 1 of 0.219. That would give you 4.556 centimeter. What? Centimeter only. Is it clear? So have we done something wrong here? We are 1 by R, 1 by rho, A by L. Okay, so good. So this will be multiply here. It will be kappa by rho. Okay, just let us see the solution where we are making mistake. So lambda m is this much, R is this much. Okay, cell constant is lambda m multiplied by R. So we have to just multiply it and you will get your answer. Okay, so let us see this question at the last. Okay, we'll try it one more time. What does the next question says? The conductivity of sodium chloride at 298 Kelvin has been determined at different concentration and the results are given below. Now calculate lambda m for all cell constant and draw a plot. So what will be lambda m? Say it will be simply alpha. So we are given the conductivity of sodium chloride. So it is strong salt. Okay. So we have to calculate lambda m. So I will calculate lambda m. So lambda m value is given. Okay, so you have to calculate it. Why it is written to calculate it? Because it is 10 square. So when you just multiply it with 10 square, then you will get your value. Sorry, divide with 10 square, then you will get your final value. Right? Clear? Now, after you get the lambda m from this values that is given, you have what will be the lambda m value? So since it is 10 square, the actual value would be 0.001237. Similarly, this will be 0.1185. Okay, just put the point left to the 2-digit left to the decimal. Once you get a lambda m, plot it against root c. So concentrations are given, take the root of it. Okay, once you plot this value, we know that from the equation that lambda m is equals to lambda naught m minus a root c. So whatever will be the intercept will be your lambda naught m. Okay, so y is equals to mx plus c. If you just compare both of these equation, Debye-Huckel-Onsager equation and this equation, so you will find that your intercept, that is your C, is equals to lambda naught m. So first plot this graph, we'll get the value. Okay, clear? Okay. So these are the values of kappa. Okay, so these are the values of kappa and not your lambda m. Right? So these are the values of kappa and not your lambda m. So this is written wrong. This is of kappa. So if you have to calculate lambda m, that would be simply kappa by C. Okay, kappa by C, that is 0.001 by 1.237. Okay, so this is a mistake. Sorry for this. Okay, so this I have done it right. Clear? Similarly, for the second value, for the third value, for the fourth value, now just plot this graph and you will get your final value. Next is the conductivity of 0.0241. So conductivity of this concentration is given. The concentration is 0.00241 m. So conductivity is kappa is given 7.896 into 10 to the power minus 5. You can see I am also making mistake. Okay, so it is obvious. So you must do it twice or thrice, so that your concept get clear. Anybody can make mistake. Okay, 390.5 Simon centimeter square per mole. We have to calculate dissociation constant. For that we need alpha. Okay, because alpha is equals to lambda m by lambda naught m. We are given the value of lambda naught m, but lambda m value is missing. So we have just seen the formula. Lambda m will be kappa by C. You have to convert this. For that, you have to divide it by, or you have to multiply it by 10 to the power minus 3. That will give you mole per centimeter cube. Okay. So 7.896 into 10 to the power minus 5 multiplied by 10 to the power 3 divided by 0.00241 into this one is this thing. Okay. So 7.896 is divided by 0.00241. Okay. And again multiplied by 10 to the power minus 2. So that will be 32.76. So it will contain a Simon, of course. Then what it will contain? So centimeter cube was on the down, it will go up. It will be centimeter and per mole. Okay. So this is lambda m. And alpha is equals to root under Ka by C. Right? Let me write it on the board. Root under Ka by C. Concentration is 0.0241. And this value I have calculated. Lambda m is 32.76. Okay, just convert this value into per centimeter. 0.0024 0.00246 to 10 to the power minus 3 by cup Ka root under. So this one is divided by lambda naught m, whose value is 390.5. You just take the square of both on the both side. Just calculate this value. Okay, so I'm not calculating it. Do it by yourself. You will get your final answer. So they've done the same thing. Lambda m kappa by C. Further, alpha is this, and alpha is root under K by C. So they have not approximated it 1 minus alpha to alpha. I have approximated it. You can do it in the either way. Right? This is the final answer. Now we will see questions from electrolysis. First question says that how much charge is required for the following reduction. Okay. We know the formula for this. M is equals to ZIT. For Z, it is molar mass by N factor. Okay. Now let us solve each of these questions one by one. The first is 1 mole of Al3 plus. Okay. So we have 1 mole of Al3 plus. And we have to convert 1 mole of Al3 plus to Al. If we just formulate this formula furthermore, so molar mass is not given. So suppose molar mass will go on this side. So weight by molar mass is multiplied by N factor. And I into T is nothing but Q. And this one is what? Number of moles. So we can write it a new formula. Number of moles multiplied by N factor is our Q. And we have to calculate this Q only. So Q will be equals to, what is the number of moles? It is 1. N factor for Al3 plus is 3. So this will be in coulomb. Okay. So if you have to find for Faraday, simply multiplied by F. Okay, just place it. Right? So this is 3 Faraday. It is your answer. Is it clear? Next question. Next question says that 1 mole of Cu2 plus is going to Cu. How you will do this? Just try it by yourself. So this question again, we are going from Cu2 plus to Cu. So the shortcut would be, I would say, Cu2 plus to Cu. So this gives you 3F. So this will simply give you 2F because 2 electrons are involved. Okay, so this will be 2F. Next one. So next one requires the calculation of the oxidation state of manganese. Let us first find the oxidation state of manganese. MnO4 minus. So let us consider it X. 4 oxygen with a charge of -2. Overall charge is -1. So that will give you a charge of +7. And we are going from +7 to +5. So 5 electron charge. So 5F. Is it clear? 3F, 2F, and 5F. Let us see the solution. So they have converted into coulomb. So coulomb will be more good. I have left it in Faraday. 2F and 5F. Is it clear? Next is how much electricity in terms of Faraday. So in this case, you have to find it in terms of Faraday. From Ca to CaCl2. So very simple. First find the number of moles from here, and for just multiply it with the N factor, you will get a final value. So the mass of molar mass of calcium is 40. Therefore, number of moles of calcium will be equals to 20 by 40, that is 1 by 2. What is N factor? Since it is Ca2 plus to Ca, it will be 2. At last, what will be the charge in terms of Faraday? It will be 2 into 1 by 2 into F, that is 1 Faraday. Clear? What about this? 40 by 40 gram by, so number of moles of aluminium will be equals to 40 by 26. Okay, multiplied by N factor is what? I'm directly finding the charge for it. So it will be multiplied by 3. 3 is the charge. Clear? So you solve this, you will get a value. Let us see the solution. So we have 1F. Okay. Next question. So it is 40 by 27. Okay, so it is approximately 27 they have taken. How much electricity is required in coulomb for the oxidation of this one? So you do it by yourself. Okay, so I am leaving it to you. Okay, it's the same question. Fe2 to Fe2 plus, Fe3 plus. Here, O oxygen positive is going to 2 negative. So it is this coulomb, and this is your 96486 coulomb. Now, next question. So this question says that we have a solution of NiNO3 whole twice, and it is electrolyzed between platinum electrolyte of 5 ampere for 20 seconds. So I is given as 5 ampere, Q is given as 20. I am converting into seconds just now, that is 200 seconds. This is T. Mass we have to calculate. What will be Z? Molar mass of this nickel. So molar mass of nickel is, let me find it for you. Molar mass of nickel is 58.6. It is 57 approximately. So Z will be 57 by, what will the charge on this? 1 NO3 is a charge of negative. So minus 1 multiplied by 2. Okay. So 2 NO3s are there. X, it is equals to 0 because the overall compound is having a 0 charge. That is plus 2. So divide by 2. So M will be equals to 5 multiplied by, sorry, Z multiplied, that is Z is 57 by 2. I, that is current, is 5. And T, it is 1200. So this will be your final answer. Okay. Next question. So they have done the same thing, calculated the charge first of all. You can do it individually or at the same time. No issues. Once we got this multiplied by 2, you will get your. Is it clear? Okay. Next question. Three electrolyte ABC containing solution of this, and this respectively are connected in series. A steady current of 1.5 ampere was passed through until 1.45 gram of silver deposited at the cathode. Okay, the mass is given here, right? W is given, and we can calculate silver Z, very easy. 108 Ag is in minus plus 1, so 108 by 1. Okay, this mass is given as 1.45. So we know the second law of electrolysis. This will be equals to the weight of ZnSO4, or Zn, I would say, not ZnSO4, Zn, divided by equivalent weight of what? Zn. So molar mass of Zn will be, so it is 65. So it will be 65.34 divided by 2. That is the N factor, because ZnSO4 will be bifurcated into Zn2 plus and SO4 2 minus. So from here you can calculate the weight of zinc, and for weight of copper it will be how much? So copper will have mass of 63.54 divided by again 2, because N factor is 2. So from equating this and this equation, you can find the weight of Cu. Is it clear? Now next question. These are the solutions. You can see it. Solutions are present everywhere, right? So is this question an aqueous solution of AgNO3 with silver chloride? What we have to predict? We have to predict the product of electrolysis. In each of the following, what will the product? So let us see the solution. These are very easy questions. So Ag plus will take a 1 electron and will form silver, okay, at cathode. If it is placed against hydrogen, then hydrogen gas will also be involved. Similarly, for the next one, this is a cathode, this is a anode. Next one also will be Ag plus will go to Ag. We have Cu2 plus, it will form Cu solid. So this is the main thing, okay. These are the just the information that is given to evaluate the things more properly, but the main thing is Cu2 plus going to Cu. Now this question, okay, this is very good question. So what does this question says? In the double bar, okay. So E0 for the cell is given. Directly it is given 1.10. We have to find the equilibrium constant. So at equilibrium, the Nernst equation becomes E naught cell will be equals to 0 minus 0.0591. So if you write the equation, you will get n is equals to 2. So I'm skipping this part. Just write by yourself. Log k, isn't it? So this value is given as 1.10. Just solve this. It will be 10 to the power. Okay. So this negative sign will go on this side. So that would be approximately 10 to the power minus 37. Okay. Clear? So with this, we have completed all the exercise of NCERT. So in the next class, we'll move to the example problem. You just solve it by yourself also. That will clear your doubts. Okay, thank you.